So hello everyone, my name is Kaushal Bodade and today I am going to tell you about 4 to 2 priority encoder using Verilog. So first we will get about what is Verilog. Verilog is a hardware description language used to model, simulate and describe electronic circuits and digital systems such as microprocessors, memories and custom hardwares. It allows engineer to define how a digital system behaves rather than how it implemented in terms of transistor and gates, which makes it widely used for designing complex digital logic systems. So in VHDL, we get all things in gates and transistors, but in this Verilog, we can see how it that system behaves. Key uses of Verilog: describing digital circuits. So first key use is describing digital circuit. Verilog lets engineer define circuits at a different level for individual logic gates to complex systems. So it helps us to define circuits at a different level and individually logic gates to complex systems. So in simulation used to verify that design works correctly before physical implementation, means it helps us in simulating all the things before implementing it on a physical level. So in synthesis, converts the design into actual hardware components for FPGAs, means field programmable gate arrays, and ASICs, means application specific integrated circuits. So we will get about now where Verilog is used. So these are the key uses of Verilog, and these are the implementation of Verilog, means where they are used. Digital system designs, creating processor, memory, and custom hardwares. In creating these processors, memories, and custom hardware, we can use Verilog. FPGAs and ASICs. FPGAs, as I said, field programmable gate arrays, means it helps Verilog helps us in developing that programmable hardwares and custom chips, means ICs or all the chips for which is Verilog use. Embedded system designing hardware that interface with software in embedded applications. So we'll get about now what is 4 to 2 encoder. So we are making that 4 to 2 encoder. But firstly, we will get know about what is 4 to 2 encoder. So in 4 to 2 encoder, it is a digital circuit that converts 4-bit input, means it has 4 inputs and into a 2-bit output signal, means it has 2 output based on priority. It compresses multiple input line into favor output lines, helping reduce the amount of data needed to represent signal. Here are four bits, mean four inputs. Four inputs usually labeled as D3 highest priority down to D0 lowest priority. This I will tell you about what is highest and what is lowest priority. But in this Verilog signal, we will use vector forms so to write it. So in it outputs, there are two outputs labeled y1 or y0, representing the binary code of highest priority. In priority encoder, the priority is assigned to the highest numbered input, means as I said here, D3 is the highest priority. D3 has highest priority, and as D0 has the lower number, D0 has lowest priority in this case. But if both inputs are active, means both D3 and D1 are active, both will be high, both will be of high priority. The encoder only consider the highest priority input, ignoring others. So these are the truth table. In this, we will get know rightly about that priority. So En is means if En is 0, there will be no supply. Means it in electronics language we can say, if En is 0, there will be no supply. If En is 1, there will be a supply. So when there is no supply, all the inputs will be 0. In electronics language, we can say that if there will be no electronic supply to anything, the output will be zero, means it does not have any output. So there will be nothing in input. So it is like that. If En is 1 and all others are 0, then y1 and y0 will be also 0. Means if inputs are 0, output will be 0. In En, if En is 1 and d0 is 1, in this case, if d0 is 1 in any case, d0 is 1 and d1, d2, d3 are 0. So y1 and y2 will be 0 in any case. If En will be 1 and d1 will be 1, if d1 will be 1 or d0 will be anything, it can be anything 1 or 0. Here are two cases, 0 and 1, and d2 is 0, d3 is 0. So in this case, if d1 will be 1 and this highest priority things are 0, the output will be 0 and 1, means y0 has 1 in its input, its output, sorry. So as d2 has 1 in its input, it has higher priority than d1. So in if d1 has 1 in its input but d2 has 1 in its input, so priority will be goes to d2. So if d2 has 1 in its input, y1 and y0 will be 1 0, means y1 will be 1 and y0 will be 0. And same as if d3 is the highest priority here. So if d3 is 1, unless anything in this d2, d1 and d0 will be ignored, and if d3 has 1 in its input, output will be same, y1 and y0 will be 1 1. So these are the truth table for it, and this is block diagram. This has 4 inputs and 2 outputs. So we will go in Verilog and see how that Verilog file is made. So we will first open the Xilinx. Okay, we will go to files, new project. We will give here a name. So it is priority for encoder 422. Next. Here we will make a source file for it. Means if we have to do in VHDL, we will do VHDL module, but now we are doing in Verilog module. So we will select Verilog. We will copy this name and next. We have to put here inputs. So we have 2 inputs. First input is EN, enable pin is our input, and second is our D. We will take a D as input here. We'll select bus, means they are vector forms, and it has 4 inputs, means 3, 0, 1, 2, and 3. There are 4 inputs. And at output we have Y and valid. Valid will be, this will be output. And Y is in vector. We will take in vector and it has 2 outputs. So 0 and 1 are 2 output. So we will go to next, finish, next, finish. So this we have now our VHDL, Verilog module. To make the Verilog picture, means text picture file, we have to go in, we have to right click on this, or we can right click on this and go to new file, select Verilog picture file, and we will copy this same name, but we will write TF, means text picture. To specify it, we will select text picture file and go to next, finish. Here we have made text picture file also and a module file also. But I have already done that things, so we will go to directly go to files. And as I have done module, so it is module and the name of that file priority encoder 422. Here inputs are enable means inputs have two pins, enable and D, and output has Y and valid. This is the most important part. We have to always write that always at the rate abstract to begin all the things. Begin, and first we will write if and else. If we will begin, if there is no en, y will be 0 0. Means y is output, so it will show 2 bits. Output 0 0. Valid is 1, it will show 1 bit. Value is 0. If en will be not there, and in else case, if en is there, if d is equals to 1000, means it has the highest priority, the y will be means output will be 1 1 and the valid will be 1. If uh, d will be 0 1 0, means d3 here has a d2 has a priority. So if d2 has a priority, there will be 1 0 in its output. If d1 has a priority, there will be 0 1 in its output. If d0 has a priority, then there will be 0 0. Or if there is nothing, so we can go for 0 0. So here we have written case, so we have to end the case, end the beginning, and also end this beginning, begin, and end the module where we have start here. And we can go to synthesis and save this file and check syntax. If it shows check, we can go for TB, means text bench file. Here is text bench file. So same as module. These are the input and outputs. These are some inputs we have given to it. If en will be 0, all the zeros. If en will be 1, start with 0 0 0. If priority goes on, it will means change the output at that phase. And this is the delay for that. Means if here hash 10 means here is a 10 delay of 10 units. So we will end the module and go in behavioral simulation, save it, and we will check the syntax. If it goes check, we will go to simulate behavior module. Thank you all of you.